So this is a continuation of the discussion of Laplace transforms. So the succeeding videos will be discussing about the different properties of Laplace transforms. And the first property of Laplace transform that we will be discussing is the linearity property. Okay, so the linearity property, so we have here the Laplace transform of a f1 of t plus b f2 of t is equal to a Laplace transform of f1 of t plus b Laplace transform of f2 of t. Okay, so what this basically means is that as you can see, we have two terms, okay, here. Okay, so this means that if our function has two or more terms, okay, then all we need to do is get the Laplace transform of each term. Okay, the a and b there are constant coefficients. Okay, so similar with integration and differentiation, so we can place the constants, okay, so outside the Laplace transform operation. Okay, so just like here. Okay, so that's basically it. Okay, so to show that property, so let's have an example. So number 1, so find the Laplace transform of f of t is equal to 2t plus 3. Okay, so we are asked to find the Laplace transform of 2t plus 3. Okay, so all we need to do is get the Laplace transform of each term. So Laplace transform of 2t, and then plus the Laplace transform of 3. Okay, so we have a constant coefficient here of 2, and then here we have a constant of 3. Then we can take it outside the integral sign. We can factor it out. Okay, so excuse for that. And then we have a constant coefficient of 2. So write that outside the integral sign. So 2 Laplace transform of t, okay, plus 3 Laplace transform of 1. Okay, so for the formulas, okay, that we have already memorized, so the Laplace transform of t is equal to 1 over s squared, sorry. So the Laplace transform of t is 1 over s squared, and the Laplace transform of 1 is 1 over s. Okay, so therefore this will become 2 Laplace transform of t is 1 over s squared, okay, plus 3 Laplace transform of 1 is 1 over s. Okay, so we can simplify that. So this will become 2 over s squared plus 3 over s. We can combine the 2. So we have least common denominator is s squared. So s squared divided by s squared, 1 times 2. So you have 2. And then s squared divided by s is s times 3. So plus 3s. So therefore that is the Laplace transform of 2t plus 3. Okay. Example, we have find the Laplace transform of t minus cosine 5t. Okay, so using the linearity property, so all we need to do is find the Laplace transform of each term. So we have Laplace transform of t minus the Laplace transform of cosine of 5t. Then applying the formulas that we have memorized. So the formula that we are going to use are the Laplace transform of t is equal to 1 over s squared, and the Laplace transform of cosine omega t is equal to that's s over s squared plus omega squared. Okay, so the Laplace transform of t is simply 1 over s squared minus the Laplace transform of cosine 5t is, so here our omega is equal to 5. Okay, so s over s squared plus 5 squared. Okay, so we can simplify that as 1 over s squared minus s over s squared plus 25. So adding those two, we will have a least common denominator of s squared times s squared plus 25. Okay, so this divided by this, so what will remain is s squared plus 25 times 1. So it will become s squared plus 25. Then this divided by this, so what will remain is s squared times s, so that is minus s cubed. Okay, so therefore, the Laplace transform of t minus cosine of 5t is equal to, you can rearrange that into negative s cubed plus s squared plus 25 over s squared times s squared plus 25. Oops, sorry. So for our final example, so find the Laplace transform of f of t is equal to hyperbolic cosine of 8t using the linearity property. Okay, so the Laplace transform of hyperbolic cosine of 80 is equal to, so from the definition of hyperbolic cosine, okay, so recall that the hyperbolic cosine of x is equal to 1/2 e raised to x plus e raised to the negative x. Okay, so it's equal to 1/2 e to the x plus 1/2 e to the negative x. Okay, so therefore this will become the Laplace transform of 1/2 e to the x plus 1/2 e to the negative x. Okay, so using the linearity property, so we will distribute the Laplace transform, so it will become the Laplace transform of 1/2 e to the, sorry, we have 80, sorry, this should be 80, and then this is negative 80. Okay, so sorry, so 1/2 e raised to 80 plus 1/2 e raised to negative a t. Okay, so this will become 1/2 the Laplace transform of e raised to 80 plus 1/2 the Laplace transform of e raised to negative 80. Okay, so recall, so from our formula, so the Laplace transform of e raised to 80 is equal to 1 over s minus a. Okay, so therefore this will become 1/2 times the Laplace transform of e raised to 80 is 1 over s minus a. Okay, and then plus 1/2. Now the Laplace transform of e raised to the negative 80, so since this is now negative, then this will now become positive, so 1 over s minus negative a, so it will become s plus a, so 1 over s plus a. Okay, so therefore this will become 1 over 2 s minus a plus 1 over 2 and then s plus a. Okay, so adding those two, so we will have a, okay, so again adding those two, we will have the least common denominator is s times s minus a, 2 times s minus a, and then s plus a. Okay, so this divided by this, so what will remain is s plus a times 1. So we have s plus a, and then plus this divided by this, so what will remain is s minus a, and then times 1, so s minus a. So simplifying, so we will have s plus a plus s minus a over 2. We can multiply this, so this is product of sum and difference, so this will become s squared minus a squared. So simplifying the numerator, so we can cancel out a, and then s plus s is 2s over 2 times s squared, 2 times s squared minus a squared. Canceling out 2, so therefore the Laplace transform of the hyperbolic cosine of 80 is equal to s over s squared minus a squared. Okay, so which is consistent with the formula that we have previously memorized. Okay, so that's all. So yeah, all you need to do is memorize the formulas, okay, for us to easily solve Laplace transform problems.